So a function is implicitly defined if there's y's in here when you cannot get this function here. You cannot get to a point where you have y equals. This is y equals, and we can take the derivative of that. But you see here, we've got the y inside the cosine and y cubed. You cannot solve for y. All right, another indication you're going to do this implicit differentiation. It'll say this is implicitly defined, given implicitly. So let's look at this. So I want to see that this y equal f of x cannot be solved for, and I want to find the derivative. So what I'm going to do is I'm going to take the derivative with respect to x on both sides. And if I do that on the left-hand side also, derivative with respect to x of f of x all to the third power. Okay, so now I'm going to take the derivative. So the derivative of x cubed with respect to x is just 3x squared, right? The letters match. Moving on to the next function, I see chain rule is going to come into play. So I'll have negative sine, whoops, I meant to write sine, negative sine, carry the angle along, because that's what you do with chain rule, and then I'm going to multiply by the derivative of the angle, which is f prime of x. All right, moving to the next side, I have a function cubed. So you know that means bring the 3 down, subtract 1 from the exponent, carry the inside function along, and then multiply by the derivative of the function. So the y prime terms would be this big term, right, because there's y prime there, and then this big term, right, y prime or f prime of x here. So I want to get these two on the same side of the equal sign. So I'll keep this one here, and I'll add this term to the other side. So I'll have 3 f of x all squared times f prime of x plus sine of f of x times f prime of x. And now I want to solve for the f prime of x. So let's look and see where the f prime of x's are. So it's here and here. So I can factor f prime of x out. And what that leaves us with is 3 f of x squared plus sine of f of x. And the left-hand side, the 3x squared just carries along. And I'm solving for this f prime of x, right? That's what I'm trying to solve for. So I'm just going to divide by this whole thing, right? I forgot the other parentheses, all of this. So it gives me 3x squared over 3 f of x, quantity squared, plus sine of f of x. And that all equals f prime of x. Okay, big and ugly, right? Now I'm going to do the same problem. I'm going to erase this. I'm going to do the same problem and just keep y for the f of x. It's going to make it much cleaner and shorter because that was pretty cumbersome to write out. Okay, so every time you're taking the derivative of y, you're thinking it's derivative of x. Sorry, derivative with respect to x of y, you're thinking, oh, that's y prime. All right, here we go. So taking the derivative with respect to x of x cubed plus cosine of y equals the derivative with respect to x of y cubed. And I only write this, you don't have to, but I only write this to emphasize x is the letter that you do the easy power rule on. So let's do it. So if I take the derivative of this term, it's 3x squared. No insides, that's just it. The derivative of cosine is negative sine. I carry the angle, and then I'm remembering, oh, that's a function. It says y is a function of x, so I'm going to multiply by y prime. And I did that same thing right here. Equal, let's do this over here, 3y squared times the derivative of the y, which is y prime. So now I'm going to add this to the other side. So I get 3x squared equals 3y squared y prime plus sine of y, y prime. And then I'm going to factor the y prime out of these two terms. 3y squared plus sine of y, 3x squared. And now I'm going to divide through by this. So let me put it down here. So 3x squared over 3y squared plus sine of y equals y prime. So if I compare this. Oh, I erased it. But it is the same where I have f of x is, the y is an f of x. So I want you to be able to do it without putting f of x's in. So let's do this next one. So the instructions will tell you whenever you see a y, that's when you know there is a function inside. So y given implicitly means you have to know that y is a function of x. So if I go take the derivative with respect to x on both sides, I get 4x cubed, right? Derivative with respect to x with an x base is just it. Now I'm doing chain rule here. 4y cubed times the derivative of y, which is y prime. And then don't forget product rule. So I'm going to say my first term is 6x, and I'm going to take the derivative of y squared, which is 2y, y prime, plus y squared times the derivative of 6x, which is 6. So identify the y prime terms. So this big guy and this big guy, those are y prime terms. So I'm just going to choose to put them all on the left-hand side. So I'm going to subtract this one over. So I'd have 4y cubed y prime minus 12xy y prime. And then I'm going to subtract this to the other side. So I'd have 6y squared minus 4x cubed. So then it's my time to factor the y prime out of these two terms. Factor out y prime. So factor out y prime, and I get 4y cubed minus 12xy, and then this side just carries along. And then I divide through by this ugly stuff. So I get y prime is 6y squared minus 4x cubed over 4y cubed minus 12xy, and we're done.